Welcome. In this lecture, I want to give another example of a function that's not continuous at a particular value of x equals a, thus it's not a continuous function. And this is going to be a jump discontinuity. So this is another way to be discontinuous. So again, we have our x-axis and our y-axis. And then we have our function, so we have y equals f of x. Okay, so this is our function y equals f of x. Okay, and how is this function y equals f of x defined? Let me try another marker. Ooh, that looks a lot better. Okay. So this is our function, y equals f of x, and how is it going to be defined? Okay, so we're going to define it by, so this is a piecewise defined function. So here, my function f of x is going to be defined by, so we have x squared for x less than or equal to 1. And then we have x plus 1 for x greater than 1. Okay, so the function is actually defined at x equals 1, right? Because we just, we're allowed to look at x less than or equal to 1 here, so that includes x equals 1. So we just define it using that function. And that kind of matches up with here. It looks like we're using the x squared part of the function. Okay, but our problem happens, so we're going to look at the value, this is going to be x equals 1, right? And then we need to look at what happens as we approach from this side, right? As the x values approach from this side, the right-hand side or left-hand side. So we're looking at values that are greater than 1 or less than 1. And what happens? So if I take the limit, right, as my x values, and I'm going to come from the left-hand side, so I'm going to look at where it's less than, okay? So the limit as x approaches 1 from the left-hand side, so we're looking at values of x that are less than 1, so I'm looking here, okay? Then what happens? So of f of x, this was the better one, so of f of x, so what ends up happening is that this is going to equal, well, as I said, because the values are less than 1, I'm allowed to use this function here. So that's my x squared. And then because this is actually defined there, I can just put 1 right into there. That's not a problem. And I get out 1. Now what happens if I approach from the right-hand side? So the limit as x approaches 1 from the right-hand side of f of x. Well, now I'm taking values that are greater than 1, so I'm looking at the function as being defined by x plus 1. So this here is going to equal, so I just will go x plus 1. I like to put parentheses where I'm going to fill in my x value. And because this is this function is actually defined at 1, I can just stick that in, right? But we're just looking at values that are close to it. Okay, but it works like this. Okay, and that's going to output for me 2. Okay, but these are not actually equal. So this tells me that f is not continuous at this value x equals 1. So what I have is that f is not continuous, so is not continuous, right, at x equals 1, right? In this case, even though it was defined at x equals 1, the limit as you put x values into the function from the left-hand side and the right-hand side at 1 do not end up being equal. Okay, so we say that f of x is going to have a jump discontinuity okay, at x equals 1. At x equals 1. Okay, so this is kind of our conclusion. The function f is not continuous. It has a jump discontinuity. And particularly the just jump discontinuity is at x equals 1. And if you look in the picture, you do see, you know, your graph, as you're kind of drawing it, you kind of have to lift up and go to a new place. You kind of have to jump your hand. Okay? So what happened here? As I put in x values that were closer and closer to 1, from the left-hand side, so I looked at values that were less than 1. So I was looking at the function as being defined like this, versus as I put in the values of x that were closer and closer to 1 from the right-hand side. Okay, so I had x is greater than 1, so my function looked like this, right? X plus 1. The values that I got were different as my output, which told me that the function is not actually continuous at that particular point, and I have a jump discontinuity. Okay, so I hope that made some sense, was helpful, and I will see you in the next lecture.